Hello everyone, on this video we will learn how to handle NetCDF data using QGIS. So at first we have to prepare the data. You may go to this address and then click on this local copy link and this link for man-graded data. In this case we will learn using precipitation data and click on this link for year 2021-2022. In this case I already downloaded it, so I will cancel this one. Okay, and then next we will use temperature data, same periods. Click on this link. I already have this one as well. Canceling. And then wetness data, same periods. Okay. I'm canceling because I already have the data. For the scientific background or for the literatures of this data, you may go to this link. And this is the publication of the data. It is published in the Scientific Data of Nature. Okay. Next, if the data already downloaded, you may go to your QGIS. The data will come in zip file, so you need to unzip the file first. And this is the NetCDF unzip file data for precipitation of the world for 24 months. So the difference between conventional TIFF and NetCDF TIFF data is in conventional TIFF, they only stored one single band, or maybe some multiple bands, but in NetCDF, they have so many bands like this. You can see there are 24 bands, which means 24 months. Okay, so we need to calculate the average, the mean of the precipitation of the world first using period or year 2022. So you may go to Raster calculator, and using bracket symbol, input the precipitation from precipitation 13, 14, 15 until 24. Okay. Okay, we close it, divide it by 12. Then you may put the name, maybe work, trip, 2022, like this. Okay, and click OK and save. Okay, because I already have it, so I will go to my data. So this is my data, world precipitation. And then I will remove this one. Now we already have the average demand for 2022. Okay, next, do the same thing for the temperature, the other data like temperature and wetness. For example, this is for NetCDF of temperature. Okay, so go back to raster calculator and do the same thing. Open the brackets, input the temperature 13 until temperature 24 and divide it by 12. Okay, I will cancel this one because I already have the temperature, world average temperature for period 2020. This one, I will remove this one. And for the last one is for the wetness data. This is wetness data. Okay, same, because this is NetCDF. They have so many layers, so we need to calculate the average first. Go to raster calculator, open the bracket, the input wetness 13, 14 until 24 and divide it by 12. Okay, I will cancel this one because I already have world temperature. Sorry, world wetness. Okay, like this. Okay, then we need to click the data based on our study area. For example, in this case, I will use India. So open the NE 10 meter administrative one state province layer, double click, put it on the top, and open the attribute table, do some basic spatial query using SQL language. Go to field, admin equal to India, and double click India and select features like this. Okay, it's already finished, and then you may zoom to selected location India, then go to raster, extraction, and click raster by mask. Input layer is precipitation. The mask layer is administrative boundary, and do not forget to check this one because we want only clip using India. Okay, target CRS is project CRS, and save it into your folder. Save to file and input, for example, India prep for 2022 like this. Okay, because I already have, I will cancel this one as well, and then I will open the India precipitation, this one. Okay, and then we will remove all of this data. We don't need these layers. Okay, then this is for India precipitation. You may change the visualization from single band to pseudo color, and for precipitation maybe you will create a new color ramp and select catalog precipitation. Scroll down, find precipitation and select rainfall. Click OK and classify, and OK. So this is your average precipitation of India of year 2022. For the others, for example, temperature and wetness, do the same thing. For example, wetness, we just make it as a blue color like this. This is wetness. Wetness is consistent with, consistent with precipitation. Okay. And then the last one is for temperature. Change the render type to single band pseudo color and select new visualization, new color ramp, CPT-CT, and select temperature. This one, click OK, classify, and OK. So this is your temperature. Okay, we can remove this layer. We don't need this one. Next, we want to extract the value because we want to do some more further statistical analysis. Okay, so you may go to processing toolbox and just type raster to point. Select this one, raster pixel to point. For example, this is precipitation, the value name is prep, and the vector point is save to file and select India prep like this. Okay, this is just for example. Okay, I already have it. I will cancel and close this one. And I will open my data. This one, India precipitation. I save it into geo package. Okay. So we can open the attribute table. And this is the precipitation data of each pixels. Next, we want to use this point. So we want to make it consistent. And we extract the temperature and wetness. Okay. We will extract the temperature and wetness. How to do this? Go to plugin. We will use profile tools plugin. We need to install first. Manage and install plugin. Just type profile and install the profile tool. Install the plugin. Close, click on this icon, and you may select precipitation, and add layer. Precipitation, change the color. Click on this box, and precipitation will be cyan or light blue like this. And temperature, Temperature is red, is fine. And the last one is wetness. For wetness, we change into dark blue like this. Okay. And then click on India precipitation point data layer, and then change from temporary polyline to selected layer. Now we have a graph like this. So you may see here, you can observe here when the precipitation become high, the temperature become low and the wetness also become high. If you have another data, for example, you want to add PM 2.5 data, you may add PM 2.5 India, and then you just add the layer, change the color, for example, to yellow, click OK, click again on India, precipitation point data layer. Okay, now you can see here, when the precipitation becomes high, PM 2.5 becomes low. And then if you want to export the data for further statistical analysis, okay, you may go to, okay, change the selected layer again. Okay, go to table and you can click on copy to clipboard, open your Excel and pass into your Excel data. This is, I already passed all of the precipitation data, temperature data, wetness data, and PM 2.5 data. Because there is some non-numerical data here like this, so you need to do some basic data cleaning before you go to another statistical analysis. You can save this data into CSV and you can do some more processing using Stata or using SPSS, or maybe you can also use Excel to do some basic regression or multiple regression analysis. Okay, I think that's all. Thank you.